Hi guys, today we're going to start our next unit about exponential and logarithmic functions, and we're going to start with a little experiment. So this is the front page of your new unit notes packet, and we're going to start with some data collection for our experiment. So we're going to start with an experiment on exponential growth, what we'll come to know as exponential growth. What I have here is a little Dixie cup and some M&Ms, and we are going to start with 2 M&Ms in our cup. Okay, and what we're going to do is dump out our M&Ms, and anytime I have an M&M facing M side up, so like I have here, I'm going to add an M&M to my cup for every M&M that lands M side up. So we'll start here. We're starting with 2 M&Ms. And on our first trial, we have 1 that lands M side up. So now we're going to add 1 since we had 1 that landed M side up. So for this next trial, I've got 3 M&Ms in my cup. Now we'll do the same thing until we don't have any more M&Ms that we can add. So this time, it's hard to see with the yellow, but all 3 of my M&Ms landed M side up. So I'm going to add 1, 2, 3 M&Ms to my cup for a total of 6. And I'll repeat this again. There's 1, 2, 3 M&Ms that landed M side up. So I will add 3 more M&Ms to my cup. So 6 plus 3 gives me a total of 9. And now I've got 1, 2, 3, 4, 5 M&Ms that landed M side up. So I'm going to add 5 M&Ms to my cup. That would be a total of 14. So 2, 4, 5. Now the total in my cup will be 14. Then back into my cup. And here are my M side up M&Ms. 1, 2, 3, 4, 5, 6, 7, 8. So I need to add 8 more M&Ms. So 2, 4, 6, 8. 14 plus 8 would give me a total of 22. One that kind of rolled way up to the top here. And let me sort out my M side M&Ms. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I need to add 14 M&Ms to my cup. 2, 4, 6, 8, 10, 12, 14. 22 plus 14 would give me 36. Okay. And we'll keep going here. We probably won't get too many more rounds before we're out of M&Ms. Looks like all of them are M side up. 2, 4, 6, 8, 10, 12, 14 again. So I'm going to add 14 more, and that would give me 50 total M&Ms. So 2, 4, 6, 8, 10, 12, 13, 14. All of these back into my cup. And again, we'll sort out our M's. I think this might be our last trial. Okay, so we're going to add 2 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. We'll have to add 28 M&Ms to our cup. I don't have 28 more M&Ms, so we'll stop our experiment here. But we would load 78 into our cup if we had that many. I'm gonna put these off to the side for now. And let's take a look at our data for just a second. So we started with 2 M&Ms, and every time that we dumped out the cup and we had a Candyland M side up, we added to that cup, we added that number to our cup. And so our last trial would have had 78 M&Ms in our cup. Since I don't have 78 M&Ms, we'll have to stop there. We don't know what would happen beyond that, but 8 trials is not too bad. So we're seeing that the number of M&Ms that we had increased each time. Now we're going to look at an experiment that's going to show us something we'll come to recognize as exponential decay. So I've got a full cup of M&Ms here. There are 65 M&Ms in this cup. We are starting with 65 M&Ms. And what we're going to do this time is when we dump out the cup, the candies that land with the M facing up, we're going to remove from our pool. We're going to remove from our cup. And what we're going to record is how many that we have left. Okay? Record the remaining M&M population. So we're starting with 65. And we're going to record however many we remove. So we're going to, I should say, we're going to record however many are left. So we are removing all of these guys. These can stay. These are going, going. It's hard to see on the yellows, but that one's just them facing up. Okay, so all of these are going. I'm going to put those off to the side and I'm going to count how many we have left. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 29. This one was M side up. So 29. We have 29 M&Ms remaining. So these are going to go back in my cup. I'm going to repeat this process again, just like I did before. And we're going to go until I've completed all the trials that I possibly can, or our population gets below 4. Oh boy. Okay. So we're removing a lot of M&Ms again. Again, anything with the M facing up, I am removing from my population. Okay, so that's all of these. And I'm left with 2, 4, 6, 8, 10. And now I'm removing all but 3. So we're going to record 3, and then we're actually going to stop our trials here. Our directions say stop when the population gets below 4. We're now below 4, so we're going to stop that second experiment. We'll put these off to the side, and now we're going to take a look at what it is that we're seeing here with our M&M experiment. So if we turn to the next page, the first thing I see here is that I'm dealing with my exponential growth information. So we're looking at that top table. And what I want to do to start is to create a scatter plot of that data. So our trial number along this axis and our number of M&Ms here. So I'm going to do 1, 2, 3, 4, 5, 6. And we got to 8 trials, 7, 8. If you wanted to label every other, that would be fine too. I just labeled every one. And then our number of M&Ms, we're going from 2 to 78. So we've got, let's see if we could go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. We're not going to be able to do that maybe by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. There'd be 75 and 80. So we could go by 5s here. Okay, and so for trial number 1, we had 2 M&Ms. For trial number 2, we had 3 M&Ms. For trial number, trial 0, we had 2 M&Ms. I'm off by just a little bit here, and then 3 M&Ms. Trial number 2, we had 6 M&Ms, and then 9, and then 14, and then 22, and then 36, and then 50, and then for our last trial, 78. So what we should be able to see from our scatter plot is that this is not a linear relationship. We do not have a straight line, okay? What we should also notice is that I don't have a parabolic curve here. I maybe could argue that this looks like part of the parabola, but I don't have the other part. What we're seeing here is not a function that we've worked with in Algebra 2 yet. This is going to be an exponential function. So now what we're going to look at is how we can represent this exponential relationship with a function. How do I get the function? So we're going to look at a couple different options here that we have to create an exponential function for our data. So the first is to write this increase as a percent, represent it as a percent. So what we're going to do is look back at our table, and for trial 1, we're going to take the number of M&Ms we had in trial 1, subtract the number we had in trial 2, and divide by, trial 0, divide by the number we had in trial 0. So new minus old divided by old. So we're looking at the percent increase for each of our new trials. So for our first data point here, we started with 2 M&Ms. Our new amount was 3, so it would be 3 minus 2 divided by 2. 3 minus 2 divided by 2. I've got my calculator here to help me out. 3 minus 2, parentheses here, 3 minus 2 divided by 2. And then I want to write this as a decimal. I'm going to make sure I get a decimal answer, 0.5 there. And then for my next box, I'm going to do the same thing, but moving forward. So this would be 6 minus 3 divided by 3. 6 minus 3 divided by 3. 6 minus 3 divided by 3. And I get 1. And then 9 minus 6 divided by 6. And I get 0.5. Then 14 minus 9 divided by 9. And that gives me 0.5 repeating. So I'm going to do 0.56. And then we have 22 minus 14 divided by 14. We get 0.57. Then 36 minus 22 divided by 22. We get 0.636, so 0.634. And we would have 50 minus 36 divided by 36. And we get 0.38 repeating, so 0.39. And then finally, 78 minus 50 divided by 50. And we get 0.56 there. Now I want to find the average of all of these percents. So I'm going to add them up and divide by 8, since I have 8 numbers here. So 0.5 plus 1 plus 0.5 plus 0.56 plus 0.57 plus 0.64 plus 0.39 plus 0.56 divided by 8, and we get 0.59 for our average there. So this is the average percent increase for all of our trials. Now, what I'm going to have you do is to write a function using this percent increase. So here's your formula that you're going to use. C is our initial amount of M&Ms. That was 2. We started with 2 M&Ms. The rate of growth that we calculated, that average rate of growth as a percent, was 0.59. And then you're going to leave T because that's number of repetitions. And you're going to create an equation by filling in C and R here. So I would like you to do that now. There's another option that we have for exponential functions, and we're going to look at that next. And that's to look at the ratio of our growth instead of as a percent, as a sort of a fraction here. So what we're going to do here is, again, calculate for each trial how we've increased that number of M&Ms, and then we'll find the average for all of our ratios. So we're going to start with trial 1 over trial 0. So well, my paper's right, I can see those. So this would be 3 over 2. So 3 divided by 2, and it doesn't say if we should use a decimal or not, so I'm going to leave it as a fraction. Actually, we'll use the decimal here since we use the decimal for the other one. So that would be 1.5. And then 6 over 3. I don't need the calculator for that one. That's going to be 2. And then 9 over 6 gives us 1.5. And then we want 14 over 9. Gives us 1.5 repeating, so we'll do 1.56. And then 22 over 14 gives us 1.57. Then we have 36 over 22. That gives us 1.636, so I'll do 1.64. 50 over 36 gives us 1.38 repeating, so 1.39. And then finally 78 over 50. That gives us 1.56. And then we're going to take the average of all of these ratios that we found. So 1.5 plus 2 plus 1.5 plus 1.56 plus 1.57 plus 1.64 plus 1.39 plus 1.56. And we're dividing by 8. 1.59. Now I want you to notice that our average from before for those percents was 0.59. In our formula here, 1 plus R, 1 plus 0.59 gives us that ratio that we're seeing here. That will be important for stuff we're going to see a little bit later. So what I want you to do now is, again, write a function for this, but this time using this other option for our formula. C is still the initial amount of M&Ms that we started with, so that's still 2. But this time A is that common ratio we found, 1.59. Okay, and then T we're still going to leave as a variable because it represents the number of repetitions that our experiment would continue. So take a minute and write your function here for number 9. Okay, and now we're going to look at the same types of work with our decay problem. Since our decay was only 4 trials here. This is going to go a little bit faster, but we're going to look at the same things. We're going to start with a little scatter plot of our function. So we had 1, 2, 3, 4. Well, actually, we only went to trial 3 because that first trial was trial 0. And then we had 65 M&Ms. I'm going to label by 5s again. 5, 10, 15, 20, 25, 30, and so on and so on. Okay, so trial 0, what we started with was 65 M&Ms. After that first trial, we're down to 29 M&Ms. So 29 M&Ms. Then we went down to 10. And then we went down to 3. So again, notice that this is not linear. These points do not follow a straight line because my decrease each time is not the same. I'm also not really looking at something quadratic here. So again, this is what we're going to come to recognize as an exponential pattern. But this time, instead of increasing, we're decreasing. Okay, that's why we're calling this section exponential decay. Now we're going to do the same work, finding that percent that we decreased by, and then finding that common ratio that we decreased by. So for our first guy here, again, new minus old divided by old. So our new was 29. 29 minus 65 divided by 65. So I get my calculator up and going here. This would be 29 minus 65 divided by 65. And I got negative 0.553, so 0.55. And then we would have 10 minus 29 divided by 29. 10 minus 29 divided by 29. And we get negative 0.655, so 0.66 I'll round to. And then we have 3 minus 10 divided by 10. 3 minus 10 divided by 10. And we get negative 0.7. I'm going to calculate the average of these. So negative 0.55 plus negative 0.66 plus negative 0.7 and divide by 3. I get negative 0.63 and then 6 repeating, so I'll do negative 0.64 there. For 13, again, I'm going to ask you to write this function here. So here's our general form, 1 plus r. So remember your r this time is negative, so 1 plus a negative number. Our initial amount of M&Ms was 65, and that rate that we're using, the average from all of our trials, negative 0.64. And again, remember, keep that variable there. So go ahead and write your equation. And now we're going to look at that common ratio aspect again. So as I turn the page here, we're going to take a look at this decay example, this decay experiment data, but again, in this ratio format. So we're going to take, for our first box here, 29 over 65. So 29 divided by 65, and I want my answer as a decimal. So I get 0.446, so 0.45. And then I would have 10 over 29. So 10 divided by 29 gives us 0.344, 0.34. And then finally, 3 over 10. 3 over 10 is going to give us 0.3. My average for all of these would be 0.45 plus 0.34 plus 0.3 divided by 3. We get 0.363 repeating, so 0.36. So again, I'm going to ask you to write a formula here using this other option that we have. Remember, C, our initial amount of M&Ms for that decay experiment was 65. And our average for those ratios was 0.36. Okay, so write your function. And again, remember, you're going to leave t because that will allow us to calculate this for any number of repetitions. Okay, so we're going to stop here. And when we see you in class, we're going to pick up with some of the examples that we kind of skipped over that you need your functions for. And we'll kind of summarize what it is we're seeing here with these equations and this information that